Okay, so let's look at one final natural deduction proof. And this one is going to be slightly more complex than the previous natural deduction proof. But I think that once it's all completed, we'll see that that wasn't so hard as long as we distinguish the argument forms and apply them correctly. Okay. Now, just looking at the premises here, okay, I see a lot of disjunctions. I see a lot of the wedges. Okay, wedge here is the main operator, wedge here is the main operator, wedge here as the main operator. Okay, so initially, I know that I'm going to be utilizing the disjunctive syllogism a lot in this proof. Okay, what we need to be thinking about is how can we start breaking apart these disjunctions, right? The disjunctive syllogism is the way we do that, right? By eliminating disjuncts, okay? Now, I also see one conditional here, right? As the disjunct in the second premise. Okay, so what that tells me is if we're gonna do anything with this conditional, once it's broken apart from the disjunction, it's going to be one of the moduses, modus ponens or modus tollens. Okay, but let's just see where the proof takes us. All right, so to begin with, it looks like there are at least two moves we can make to get the proof up and running. Okay, so I see that 2 and 3, they're both disjuncts. Okay, and I see that both 2 and 3 have R as a disjunct, right? So looking at 4, I see that R is negated, right? So looks like we could use not R in 4 as a disjunctive syllogism with 2 or 3, okay? So I'll just go ahead and apply it to the disjunction in 2 here, okay? So we're gonna start with 2 and 4 as a disjunctive syllogism, right? So 2, if we wanted to read it, either R or if Q, then R. Not R, right? We're eliminating one of the disjuncts, so this other disjunct follows. So if Q, then R. Okay. Now, it's important to keep in mind, again, that with the disjunctive syllogism, all we are doing is negating one of the disjuncts, right? We are eliminating it, all right? And we do nothing with the truth values, right? We don't need to apply negations to this other disjunct. Nothing like that, okay? Everything remains intact in terms of truth values, all right? Now, what we want to discover in this proof is F, okay? So it looks like we're going to need to get this on its own, this disjunct in this disjunction, right? Because here is F, and it's the only place in the premises where I see an F, okay? So, thinking ahead, we're going to need to break that disjunction apart, right, at some point. So we're going to need to get a not Q, all right? But let's not get ahead of ourselves. All right, let's use 4 once more, okay? And we've already used 4 to eliminate this disjunct in 2. Well, we can do the same thing with 3, right? Because here we have either R or not H. 4, we're eliminating R as a disjunct in 3. Okay, so it's going to be 3 and 4 using the disjunctive syllogism. Okay, so R is not the case, so this disjunct follows. Not H. Again, do nothing to the truth value. Okay, the negation remains intact there. All right, now it looks like there is one of the moduses that we can apply at this point, right? And it looks like we're going to be able to apply the modus tollens using 4 and 5, right? So according to modus tollens, if we have a conditional here in the generic form, if P then Q, not Q, therefore not P, right? Whenever we eliminate the consequent, you have to eliminate the antecedent as well, right? Given the logic of a conditional, right? So looking at 4 and 5, right? 5 as a conditional, if Q then R, right? 4 we're eliminating, right? We're denying that R is the case, the consequent. Whenever we deny the consequent, you also have to deny the antecedent, okay? And we get that from 4 and 5 via a modus tollens, okay? So this Q is going to come in handy at some point further in the proof, right? Given that we need F on its own. But let's see how that works. All right, so a few more steps in the proof here, right? And hopefully we will be arriving at F soon, all right? Now, it looks like we can now utilize one with a disjunctive syllogism. So either H or either Q or F. Look at 6 here, okay? 6 is the negation of the disjunct here in 1, H, opposite truth values, okay? Looking at the disjunctive syllogism, when we eliminate one of the disjuncts, the other disjunct follows, okay? So not H, therefore either Q or F. Okay. So now it looks like we're in a really good spot to get our conclusion, right? We've got either Q or F, this disjunction, all on its own, okay? And it looks like there's only one final step for us. Okay, now looking at 7 and 8, whoops, we got this from 1 and 6, right? Through disjunctive syllogism. All right, always keep track of your justification there, okay? Now looking at 7 and 8, okay? 8 is a disjunction. There's only one of the argument forms that we can use the disjunction, or I'm sorry, the disjunctive syllogism with, right? And it's those with the disjunction as a premise, okay? So 8, either Q or F. 7, this disjunction is not the case, not Q. So the other disjunct follows. We get that from 7 and 8, disjunctive syllogism. Okay, so looking through the proof, right, we see that we utilize the disjunctive syllogism with abandon, but that's explainable given the presence of all the disjunctions in the original premises. Okay, so here we have 9 steps in the proof. And this is not uncommon. Expect to see proofs running this long, if not slightly longer, 10, 11 steps. But again, this was just one way of several different ways of completing the proof, right? And if you found that when you completed the proof, you say had a different step for 7, totally fine. As long as you arrive at the conclusion through a series of valid inferences here, right, you're okay, regardless of how you get there, okay? So this is as complex as it's going to get with the natural deduction. If you follow along, you're going to be able to do this just fine. And I recommend, as any math professor would recommend, practice, practice, practice. It's the only way to get this stuff down, just getting in the routine and the rhythm of completing the proofs. And, watch these videos several times to get a sense of how to get the proofs going and how to complete them.